Conduit skill bending is one of the important skill that you require as an electrical engineer, and this one is basically because of the aesthetics. And in many exam scenarios you are always presented with a layout diagram, and this layout diagram will show you how the actual installation is expected to look like. And in conduit installation, many a times you're going to encounter these two type of bends, either a 90-degree bend or an offset. So this 90-degree bend, it's easy to make because so long as you know the distance from there to there and the distance from here to here, you are going to know where to bend exactly. But in other situation whereby you have an offset like this one, and this offset can be 45 degrees, 30 degrees, etc. So you're presented with an offset like this one, like that one, and in many cases you're given the distance from here to here and the distance from here to here, the rise of the bend, and distance from there maybe to up there, wherever we have the bulb, see, the lighting point. So you have a task of identifying how are you going to make this bend to ensure that it's 45 degree with the horizontal and still maintain the given rise here. So let's say for example you're given here to be 200, you're given the rise here to be 150, and you're given the distance there to be 200. But let's don't look at that, but focus on these two measurements here. So if this is supposed to be a 90-degree bend, let me draw it on a different slate. Okay, so if you have a 90-degree, not just a 90-degree bend, sorry, but an offset with a rise, so with a rise of the distance from here up to here is 150, and you're supposed to make it 45 with the horizontal. So how are we going to do that? Many students make the mistake of taking their conduit, the full length conduit they're having, and they measure the distance from here, they measure the distance up to, then instead of measuring this distance here, they measure this distance here, all right, and they use it, they add it here, and they continue with the measurement. So they measure 150 from here up to here, they measure the distance 200 there. So you realize when you come to make this bend, your 150 will get to some place like that place over there, and you realize that one will not factor in this the actual distance that is required here, and you end up having a rise that is not 150 here because you are this slanting height here, the hypotenuse over here, did not factor in the rise that we have here. So remember always that the distance you're given 150 here, this is always the rise. So what we want also to identify is what will be the distance from this place to that place, and that's where now mathematics comes in. So you see, we have an hypotenuse here, then we have a rise of 150 here, and we know that our offset is 45 degrees. So basically we are going to employ the use of the trigonometric ratio, which is we have the three of them. We have the sine, the tan, and the cosine. So whereby we have this mnemonic to remember them is called SOHCAHTOA, whereby we have sine is opposite of hypotenuse, cosine we say is adjacent of hypotenuse, then tan is opposite of adjacent. But now we have been given this side, which is 150, which is our rise of the conduit, and we need to establish what will be the distance from here up to here. All right, and we know that our angle of the offset is 45 degrees. So basically what you're going to use, you can see we have the opposite, and we need to get the hypotenuse. Therefore we are going to employ the use of sine. So let's see how that plays out. So we have our offset here. So we have a rise of 150, we have an angle of 45 here. So we said that we're going to use sine, such that sine is equal to opposite over adjacent. Okay, so what is our opposite?